Hello everyone. Today we are starting Unit 8 of UGC NET JRF Forensic Science. This is the part 1 in which we will discuss about fingerprints. So fingerprints start developing in the 10th week of pregnancy and will be completed or become permanent by the 17th week. Dactyloscopy is the study of fingerprints. The lines that we see in a fingerprint pattern are known as papillary or friction ridges, whereas the grooves that help in the formation of this pattern, between two ridges there are grooves. So uh, the valley is known as the grooves or the furrows. Dermatoglyphics is the study of friction ridges or the ridges present in the fingerprints. Perspiration is the discharge which comes out of the pores present on the ridges. It is composed of 98% water, 2% organic acids, salts mainly sodium, urea, and small quantity of albumin. The nascent ridges are the less developed fragmented ridges that are not completely developed, and these have fragments. Uh, the possibility that someone will have the same fingerprint. So the possibility is 1 in 64 billion as per Gallen's publication. Now, how these fingerprints or fingerprint patterns are formed? So between the epidermis and dermis, there is another layer known as dermal papilla. This layer grows faster than the above mentioned two layers, that are epidermis and dermis. As it grows faster, it will make folds, and these folds will result in the formation of fingerprints. That is why it is not very easy to destroy the fingerprint patterns, as they are not present on the upper layer, they are not present on the epidermis, they are present on the layer beneath epidermis, that is dermal papillae. Then there is dermis layer. The uppermost layer of dermis is papillary dermis and lower layer is reticular dermis. Epidermal layers are stratum corneum, stratum lucidum, stratum granulosum, stratum spinosum, stratum germinativum, and stratum bacilli. The sweat glands, there are two, eccrine and apocrine. Eccrine are found in the ridged skin, whereas apocrine are present in the hair, found in the hair follicle. Sebaceous and endocrine glands are not present in the palmar or plantar surface on the hands or the feet. Zygotic twins may have identical fingerprints. Now, individuality of fingerprints. Why fingerprints are used for identification purposes? Because of their uniqueness, their permanence, their universality, simplicity of recording, and simplicity of classification. The history of fingerprints. So G.C.A. Mayer gave the theory of uniqueness of fingerprints that states the arrangement of friction ridges is never duplicated in two individuals. So fingerprints are unique. Sir William Herschel, British administrator Bengal, recorded the handprints of natives on the contract. So he first used uh, fingerprints or handprints for legal purposes. Dr. Henry Fuld said that fingerprint can be used in criminal investigation. Sir Francis Galton wrote the first book, Fingerprints, and he described the classification of fingerprints. Sir Edward Henry, Inspector General of Police, Bengal, introduced they recorded fingerprints of the criminals and maintained them. they did the classification based on these fingerprints. Khan Bahadur Azizul Haq gave the mathematical formula 1024, and Rai Bahadur Hemchandra Bose extended Henry's 10-digit classification system. We will discuss about these things in detail later in this video. Fingerprint examination. So there are different levels. In level 1, we will see the pattern. Which type of pattern is that on the fingerprint. In level 2, we will talk about the minutiae or the rich characteristics. In level 3, we will talk about the poroscopy or the study of pores, and edgescopy, study of edges. So ACEV in fingerprints is analysis, comparison, evaluation and verification of fingerprint pattern. Fingerprint patterns. Fingerprints are broadly classified into whorls, loops and arc. In arc, there are two types of arc, plain arc and tented arc. So, this type of pattern is seen in arc with no delta or no core. The tented arc forms triangle-like pattern. Ulnar loop and radial loop. These are the two types of loop. It depends on we have two bones, radius and ulna. So when the loop is towards the thumb side, it will be radial loop, and when the loop is towards the little finger side, it will be ulnar loop. So in the direction of loop will tell us the type of loop. There is one delta in loop pattern. Whorl are made up of circles, you can say. In plain whorl, there is a circular arrangement and there will be two deltas, one there and one this side, and one core. Central pocket loop is when the whorl is inside the loop. It is known as central pocket loop. Double loop whorl is when there are two loops that one above the other. These are arranged in S-like pattern. Accidental whorl, the fingerprint pattern that seems like whorl but did not follow, like the deltas and the cores, it did not follow the basic rules of being whorl. So loops are 60 to 65% common. So these are the most common fingerprint pattern. It always have a core and a delta. Core is the center and delta is the triangular terminus. It is further divided into radial loop when the opening is towards the thumb, ulnar when the opening is towards the little finger. Then comes the whorls, which have two deltas and at least one ridge, making a complete circuit or a complete circle. Arc. In this type, the ridges run from one side to the other and there is no delta and there is no core. They are divided into plain arc and tented arc. Composites are less than 30% common. So these are the combination of the above, the combination of two classes from the above three classes. And it can be central pocket loop, lateral pocket loop, twin loop, etc. The various types of fingerprint evidences found on the crime scene are latent prints, which are invisible, also known as hidden prints that are made by the oil or other body secretions. Patent prints, which are visible, these are the 2D prints. Plastic prints are the 3D prints. They are made by the indentations in the soft material like clay. The pattern areas of loops and whorls are enclosed by type lines. Type lines are the two innermost ridges which first start parallel, then diverge, and then surround the whole pattern area. Now, starting with level 2 characteristics, that are ridge characteristics or minutiae. So there are variety of patterns or characteristics that are ridge ending, short ridge, dot or fragment, bifurcation, double bifurcation, trifurcation, bridge, island, enclosure, spur, etc. are visible in the fingerprint patterns. The pattern formed by the ridges. After identifying that the suspect pattern and the sample pattern is similar, for example say loop, then we will see the ridge characteristics. Minimum 8 ridge characteristics should be similar in both the samples at the same position. Ridge characteristics are also known as Galton detail, ridge ending, or ridge detail. Anastomosis or enclosure is the ridge characteristic when the ridge, as you can see here, the single ridge will get divided into two, form a complete circle and becomes a single ridge again. So this type of ridge characteristic is known as eye or anastomosis or enclosure. In bridge, there are two ridges that are joined by a small ridge. In ridge ending, there will be two ridges, three ridges. Between them, there is a fragmented ridges or nascent ridge. In island or short ridge, there will be two ridges forming uh, a steep and then continuing. Delta, I have already explained the triangular like pattern. Bifurcation or fork, the division of one ridge into two. Trifurcation is the division of one ridge into three. Double bifurcation is after the division of one ridge into two, the other arm of the ridge again get divided into two. Dot is similar to island, but there is a dot inside the two ridges. Spur is a small hook-like pattern. Techniques for development of latent fingerprints or invisible fingerprints to the naked eye. So based on the principle that only ridges have pores from which there will be perspiration. So the pattern developed from this perspiration would be the fingerprint pattern. So when we react, the components present in the perspiration or say oil, sweat, water, etc. So we can make them visible. Physical methods are based on the fact that perspiration and greasy matter will retain the substances, some kind of substances, say example iodine or powder, without fusion, without making a new compound. They just stick to the where the greasy matter is present, and the fingerprint will be visible. Whereas chemical methods alter the component of perspiration, they react with the compound. Say for example, amino acid will react with ninhydrin and then will form a color. Now physical methods reacts mostly with the triglycerides. The first one is black powder, which is made up of lamp black, graphite or charcoal. It contains mixture of heavy salts such as manganese dioxide and graphite powder. The powder will adhere to the perspiration components such as water and fatty acid. It is useful for newer prints or fresh prints only. not for the older ones. Camel hair brush is used to apply that black powder, and it is used on smooth or non-porous surfaces. White or grey powder consists of titanium dioxide, zinc oxide, and gum acacia. Grey powder consists of mercury and chalk. It is applied on glassware, silverware, and plated surfaces. Again, smooth surfaces. Red powder is due to the red resin from the fruit of palm. After applying the red powder, the print is gently heated. The fingerprint pattern that developed, also known as dragon's blood. Amido black reagent will give blue-black color product with proteins in blood. Silver powder is suitable for hard surfaces that are dry painted surface, polished or varnished, feather, cell phone, etc. Fluorescent powder. Fluorescent powder are used on multicolor surfaces in which a single color pattern would not be that much clear. So these fluorescent powders are used and the fingerprint pattern is developed, and after the development it is exposed to UV or alternate light source. It is applied with the help of camel hair brush. Example of fluorescent powders are anthracene and rhodamine powders. Now last is the magnetic powder. It is applied using magna brush. It forms the pattern by connecting with the oily residue. The iron fillings are rubbed over the print surface. These iron fillings contain the colorant. So in magna brush, there are iron fillings. So when it comes in contact with the magnetic powder, the powder get adhered to these iron fillings and then rubbed over the surface and gives the pattern. Chemical methods. First is ninhydrin. It reacts with the amino acid present in the fingerprint pattern to form Raman's purple. Purple blueprint is formed. Cyanoacrylate vapor. It also reacts with amino acid and gives white print. Silver nitrate reacts with chlorine from NaCl or salt in sweat and forms silver chloride, and the print is black or reddish brown print. Iodine fuming combines with carbohydrate present in sweat. Brownish print is formed and it will fade quickly, so it has to be photographed or sprayed with starch solution. Other chemical method is DFO or diazofluoranone. DFO reacts with the amino acid and forms pale pinkish purple luminescent pattern. It is used on porous surfaces like paper and wood. The fluorescent excitation wavelength is at 470 nanometer and the emission wavelength is at 570 nanometer. When the print is illuminated with green light, it shows strong fluorescence which is photographed through an orange or red filter. Silver iodine plate transfer method is used to develop latent fingerprints on human skin. Latent fingerprints on fingernails can be developed using copper powder. Small particle reagent method or SPR is used for the development of prints on wet non-porous surfaces. SPR gets attached to the oily or fatty components of the fingerprint pattern, and then the fingerprint mark is the latent fingerprint marks are produced. Vacuum metal deposition method. It is used for non-porous surfaces. Cadmium is not preferably used as it is toxic. In vacuum metal deposition, first layer is made up of gold and the second layer is made up of zinc. Others include indane-dione. So amino acid present in the fingerprint pattern will react with the indane-dione to develop latent finger marks. 5-MTN or methyl thionanhydrin hemikettle used for the development of latent fingerprint. It is a sulfur analog of ninhydrin and it has both the characteristics of DFO and 1,2-indane-dione. So it is used in porous and non-porous surfaces both. Calcium chloride crystals, these are the components of iodine fuming gun and uh, are used to develop latent fingerprints. So iodine will help in the visualization of the fingerprint mark and calcium chloride crystals will absorb the moisture. Gentian violet method or sticky side powder is used for fingerprint development on adhesive type of the tape, adhesive side of the tape. Quantum dots nanoparticle method for fingerprint development. Comesse blue used for blood stained print. Alpha naphthoflavone used for fixing latent prints developed with iodine. Starch can also be used. Analyzing techniques. So first the fingerprints are collected as tap print or plain print and roll print. The finger is rolled in from one side to the other to have a complete print. So instead of ink and paper, we can also use digital capture devices such as live scan. Another is reflected ultraviolet imaging system or RUVIS to develop or to locate the prints on non-absorbent surfaces, and it does not use any chemical or powder treatment method. Because of ultraviolet radiation we can see the fingerprint pattern even if it is latent. So next is super glue fuming. Super glue is 98 to 99% cyanoacrylate ester. It interacts with the latent print and forms a complete pattern. In gel form, it is known as hard or true evidence. Laser or light amplified stimulated emission of radiations. Laser light can also be used for the same purpose. Facts or fingerprint analysis criminal tracing system. AFIS or the automated fingerprint identification system. It is a kind of database with which we can compare. So it was first used in 1971 by Royal Canadian Mounted Police. National Fingerprint File or Interstate Identification Index is a part of AFIS which is responsible for fast and accurate identification of a person with uh, prior criminal history records. So if there is a criminal history of that person, his fingerprints will be recorded in the database and we can match them and find the culprit. System of classification of fingerprints. Henry's 10-digit classification system. So the patterns are given numbers or letters. So based on these numbers and letters, a unique number is generated for every individual on the basis of the fingerprints present on the fingers or thumbs. So all the 10 fingerprints of that individual. Single digit system are chance print which include only single fingerprint classification. In case of amputation of one finger, where say one person does not have little finger, so the same finger of the other hand can be considered as for classification. The 10-digit fingerprint slip, which contains the 10 fingerprints, are analyzed based on the 7 classification system that are primary, major division, secondary, Subsecondary, second subsecondary, final and key. Primary classification. So first we will number the fingers of right hand. Thumb will be given 1, index 2, middle 3, ring 4, little 5. And then left thumb 6, left index 7, left middle 8, left ring 9, left little 10. So then 2, 4, 6, 8, 10 as numerators, and 1, the odd ones, the 1, 3, 5, 7 and 9 as the denominators. So as you can see here, right index 2, right ring 4, left thumb 6, left middle 8, left little 10. And in the denominator we have right thumb 1, right middle 3, right little 5, left index 7 and left ring 9. So even by odd. Plus 1. The value of loop for each pair is 0. There will be no value of loop. 0 will be considered. The value of whirl. For this pair, the value of whirl is 16. For this, it is 8, 4, 2, 1. These 5 pair will provide 1024 possible combinations, or these are termed as pigeonholes. If somebody has all whorls on their fingerprints, so the value would be 32 by 32. If somebody has only loops, so the value would be only 1, 0 at all the sides. Now the second classification system, major classification system. The value of right thumb as numerator, left thumb as denominator. In case loops are present, the ridges from the core and delta are counted. These are known as ridge counting. So in I type, the ridges are up to 12. In M type, the ridges are between 13 to 19. And in O type, the ridges are between 20 or more. Secondary classification system, right index by left index, in which the pattern are identified as alphabets. So arc, tented arc, ulnar loop, radial loop, whirl, composite, double loop and accidental. Subsecondary classification system, the pattern on the index, middle and ring finger of both the hands are analyzed. If the pattern is present on the right, so it would be A. Then for A for arc, tented arc, radial loop, then ridge counting or ridge tracing, index, middle and ring. For index, if the ridge counting is between 1 to 5, it is denoted as I. If it is in 6 to 12 M, more than 13, O. For middle, I is 1 to 6, M 7 to 13. These are the ridge countings. And more than 14 is O. Ring 1 to 7, M 1 to 8 to 14 and more than 15 is O. So there would be lettered group classification and also classification based on ridge counting or ridge tracing. Second subsecondary classification system, these are based on an ulnar loop, composite, whirl, double loop and accidental patterns present on the middle left and right finger. So the right middle by left middle. Final classification system, right little by left little finger and counting the number of ridges in case of loops. Key classification system, the pattern based on right thumb only. Ridge counting will be done in case of loop and whirl. The tools used for classification of fingerprints. So Batley's lens has a number of concentric circles and it is used for single fingerprint classification based on the location of core and delta in these circles. JPEG compression standards were recommended by NIST for fingerprints. Thank you for watching. Stay tuned for more such videos.